All right, let's get started. I hope everyone had a nice weekend. So today we're going to go again through a new set of lecture slides with STDIO, redirection, and symbols. Homework 1 has been assigned. So if you go all the way down, we have homework 01. It's due next Wednesday. So you have over a week to do it. It's very similar to what I did this summer, almost the same. I just want to draw your attention to a couple instructions. So this is, if you don't already have a GitHub account, this is taking you through how to create a GitHub account. You're going to create a repository on GitHub. You'll set up your command line for Git in the labs. We'll use this for the other homeworks probably. So you can create some scripts and everything that are helpful for you throughout your career. And we'll upload them to GitHub. They'll be public, so don't put anything like passwords or anything in there, anything identifiable really. So yeah, the first part's just getting you set up with GitHub or Git on the command line to link your GitHub account with the actual Git on the Linux labs. So what I want to draw your attention to is this part right here, this statement right here. So throughout section 4, when you're using Git, I expect you to record all your commands that you use to create directories, files, anything. Writing inside of files, I want you to basically write a small little report. I don't say that I want you to, I might actually change the submissions and put where you need to write up a small little summary of what you did, as well as what commands you did in like an actual like somewhat report format, rather than just giving me a file full of commands. But you must record all the correct commands you use for this part and add them to a file or something. Like I said, I'm probably going to change this a little bit to where at the end it just says, okay, you just need to submit a text file. So if I go to submissions, it says just submit your a text file called homework.txt with the URL of your GitHub page. So your repository that you create in this lab, I want you to link it. Give me the URL for it. And I'm going to go to that URL, or the TA will, and make sure it exists and do a couple more checks. And then we'll, like I said, I'm going to change the submission, and you're going to write a small little like 1 or 2 page report that I did this and this step properly. I had trouble with this, yada, yada, yada. Okay. So, yeah. So you'll submit the URL of your GitHub repository and a small little 1 or 2 page report. But in the meantime, you can go ahead and get started with creating your account, going through setting up Git, and whatnot. So it's long, so I would advise you to read through the document before starting it, rather than just starting it from the scratch and going down. Because I had a lot of people in the summer who did not read these 2 statements and then came to me at the end of the week when it was supposed to be due and said, I didn't record all my things, so now I got to redo the entire assignment. Well, you can get them. So this section 6 I added here, if you forget to record the commands you used during the assignment, you can get them through your bash history. This tells you go look at the bash history file in your home directory. It has a list and history of all the commands you used, except the ones that you used in Vim. You can copy the last however many things that were to do with your assignment using the tail command and put it in a file. But yeah, so this is the assignment. It looks intimidating right now. It's not too intimidating. This is just getting you set up with GitHub. We're probably going to use it throughout the semester. This summer, this is all I did with GitHub, but I want to use it more this semester. Because now we're actually ahead of what the summer was. I had to modify my slides today because we're actually ahead of where the summer was. So yeah, homework 1 is assigned. It's due next Wednesday, so you have over a week. If we need to extend it by a couple more days, maybe have it 2 weeks instead of a week and a half, I might. We'll see how it goes. So did you have a question?
Do you have to remote into like where we work in the lab to do this?
So you have 2 options, and it's your responsibility to figure out which of these fits for you. You can either go to the labs and finish your homeworks or whatnot, or you can remote in. If you remote in, it's your responsibility to learn how to do it and get it done by the due date. if you have trouble with remoting in, that is not an excuse to not do your homework, right? You're responsible for getting your homework done, whether that means going to the lab and doing it or remoting in. Don't come to me Wednesday of next week when it's due and say, hey, I wasn't able to remote into the lab, I didn't do it, I'm not going to be sympathetic. It's your responsibility as a college student to figure out how to do your homework and which is what's best for you. Okay, so going forward, I'm going to be a little bit more strict about some things because there's 120 of you and I'm having a really hard time keeping up with emails. Some of you probably have seen that I just don't respond for a couple days. That's because I'm a college student. I'm a PhD student. I have my own responsibilities and papers I need to write and finish. But going forward, the idea behind the labs was that you finish the labs inside the lab section on Wednesday in the 50 minutes. Sometimes it's my fault that you don't finish the labs because I blabber on through the demo. If that's my case, I will tell you to submit something and you'll get credit either way. If you don't finish the lab, but most of everyone else does, then you'll need to submit it by the Friday, the end of the week. So Friday, each week, to not get points off. If you submit it after that Friday, you're gonna get points off. And it'll probably follow the 10% each day reduction, like all the other assignments, homework assignments do. So I expect at the end of each week on Fridays that all the labs are submitted, otherwise you get points off. But this way, if you miss the lab, you can make it up, or if you have trouble with the lab and you need help, you can come on Friday to my office hours, I can help you, we can get it submitted, so you're done. But I don't want to have going week to week, okay, I didn't finish the lab last week, okay, now I got to finish it the next week, and it becomes a mess. So I'm setting a hard date, Friday, please have your labs in. Otherwise, points are taken off, 10% per day, just like the syllabus says with the homeworks. And I'll probably modify the syllabus to say this. So yeah, this is homework 1. Please try to complete it. Send me emails if you have questions. I'll probably update the submission part. You'll write a report instead of a homework.txt. You'll just put the URL in it or whatnot. But at least read through it now, because none of the content's going to change, just what you submit is going to change. Okay, so if you saw my email earlier today, we will be having a quiz on Wednesday in class. I am probably going to do a Kahoot on Wednesday to review what we've done so far and what we've covered so far in the class. Haven't decided yet. Somebody have a question? Okay. All right, so there will be a quiz on Wednesday, so please come to lab. I'm going to be a little bit less strict about you coming to lab, unless there's a quiz, obviously. If you can complete the labs going forward without coming to class by Fridays on your own, and you're resourceful enough to figure it out and confident enough to do that, you don't have to come to labs on Wednesdays anymore. But know that if you don't submit something like worthy of getting a good grade, then obviously we can take off points. But if you choose to not show up on labs the weeks we don't have quizzes, then, and you can complete your lab assignments and stuff like sufficiently with good quality, then you obviously deserve a good grade on your lab. So, but the reason I didn't do that at the beginning of the semester is because I want you to at least come for the basics, so I don't you don't get at the end of the semester saying, oh, I didn't show up, and then you didn't get the basics and whatnot. So I'd advise you still to come to lab because it's probably worthwhile. You can get feedback and whatnot, but it's not a huge deal as long as you get it done by Friday each week. Okay. So, and they'll be posted the morning or the morning before under lab instructions. So in here, all the labs, previous labs are here. So you should see lab 04 probably Wednesday morning or Tuesday night. Okay. And then obviously the YouTube is continuing to be updated if you miss the lectures. Okay, so let's get going with today's lecture. All right. So, make sure I'm recording as always. Yep, okay. So this week we're going to go over standard input and output on the command line and redirecting, how to redirect it and kind of change things around. All right, so as I mentioned, quiz Wednesday, homework due next week, and then finish lab assignments by Friday. I'll modify the syllabus probably later this week. All right, so recap, we've done a lot so far. We've covered a little bit on Git. Your homework's going to be going more in depth on Git and GitHub, so you can start getting a feel for it and using it, because almost all jobs that require code development and everything use some form of Git or version control. So it's a critical skill. I would hope you would learn it before your senior year, when you have your capstone project. That's when most people learn it. That's when I learned it, but I wish I would have learned it a lot sooner.
What year?
My senior year. So when you get in capstone at the end of your college career as a computer science or computer engineering student, you'll have a capstone project, which goes over 2 semesters. And you'll do a website or app or game or something like that. And I think one of the requirements for that capstone project is using GitHub or Git. And you have to update it and use it for collaboration, because you're going to have team members that you're going to have to do stuff with. So you're going to need to know this. And it's a lot more useful if you learn it now versus when you have to learn it in capstone. So, and we wrote our first script. So this is the part that we're ahead of the summer group. We're way ahead, because I didn't start scripting until like 2 more weeks in the summer. So, all right, quick review from last week. What are options? These are these -R, -F, -V, things like flags that you're adding to commands to give them more functionality. So we have rm-r that allows things to be recursively deleted, like directories and files inside of it. We have -F for force. We have -V for verbose. And every command has its own versions of kind of these flags or similar. And you use the man pages or Google to figure out what these options are. What are command line arguments? So the text or the files that you're passing into your command to do something on, like cat, for example. You cat a file. The file is your command line argument. And then we index these, right? These command line arguments are indexed from 0 to however many you give it. All right, so today, first going to go over the idea of standard in, standard out, standard error. We'll learn how to redirect them with these operators. So we have these angle brackets, and they all do special things as far as standard in, standard out, and standard error. We'll learn how to chain commands together so you can make more complex things with pipes. And then we'll learn a couple other extra special symbols with wildcards. Okay, so what is redirection? It's simply taking the output of one command and putting it into another, or taking it the input somewhere. It's like just taking data and moving it somewhere else, right? So we're redirecting our data or output of a command or whatnot. And you can do this with several different things in mind. You can redirect it into a file. You can redirect the contents of a file into something. You can redirect your error messages to a file or something like that. That's really the basis of, and I guess the more useful part is redirecting things to files, which we'll see in a second. Okay, so standard output, all 3 of the standard out, standard in, standard error, all default to the terminal by default. So these 3 are all by default the terminal, or the bash session that you're in. But you can change where they go or lead to. So let's talk about redirecting standard output first. So if you have a command and you want to redirect its output, so if you have cat or echo or something like these commands that output something, you can redirect standard output with the greater than symbol or right angle bracket. And there's 2 different types. So there's either a single angle bracket or 2 angle brackets. So you got this one versus this one. And they do 2 different things. So the single one overwrites your output. So if you're redirecting something to a file and use one angle bracket, then it overwrites that entire file. Whereas if you use the double angle brackets or greater than symbols, it appends to the file, to the end of the file. So it just adds on to the file instead of just overwriting. So let's do a quick little demo of this. So if we do desktop, and make directory demo, demo, and I do echo hello world. And we'll talk about why I put a backslash in a second. And we put this in file.txt. So if I do that, we just created the demo directory. So now we have a file.txt after I run the echo command, this command right here. Because it says, okay, I'm going to take this hello world and write it to the file.txt. Instead of saying, if we just put echo hello world like this, it just prints it out to the terminal, right? Whereas if you do it to a file, then it just puts it in the file. So if I view file.txt, it's got hello world in it. So it just takes the output and writes it into a file. It redirects the output to a file. All right. So now, if I say, okay, I do the same thing, but now I use the double angle brackets, and I'm going to change this to a robot, and now I view file.txt. Now it added hello robot to the end of the file, so it appended it onto the end of the file. So it's taking what I'm outputting using the echo command and putting in at the end of the file. So let's say I do it with cat, maybe. So cat file.text, normally it would just print it out to the terminal. That's standard output. If I do cat file.txt and append it to file.txt, well, you'll see that this is an issue. Anybody have an idea of why this is an issue? Why you can't just cat a file to itself and redirect it to itself? Any ideas?
Does it not exist yet?
So that's kind of on the right track of thought track. So it's because you're trying to read a file and then write to it immediately after, right? It's you're having like a conflict of you're trying to read the file, but you're also trying to write to the file. So you're creating this like dependency handler. But we can do this with another file. So if we do cat file.text, let's do file2.txt. Oh, I gotta actually put my redirects in, and if we do it a couple times, we view file2.txt, you see that it's writing the contents of file.txt to file2.txt over and over again with the append operator. So, all right. So again, if you do echo something, CSCE 215, and then redirect using the redirection operators and append it using the two angle brackets, it just places it at the end of the file. So it just places it at the end of the file. It just appends it to the end of the file. All right. So the other two versions over here, these are more specific. So putting a 1 before the angle brackets just specifies standard out, right? Your redirect, it just says, hey, I'm being more explicit. I'm making sure I only redirect standard out. Whereas these are kind of implicit. They're not very specific about which of the different outputs, inputs, or whatever standard I/O that you're trying to redirect. So this is more specific, but for the most case, you only really need to use these two. 1 angle bracket and 2 angle brackets. All right, so there's some examples there on the slides if you want to look at it later. All right, so now if we want to do standard error, we have to be more specific because by default, those angle brackets default to standard out. So if you want to specify standard error to be redirected, you just put a 2 in front of it. You put 2, and then the same rules apply. If you have 1 angle bracket, it overwrites the file. So that means that anything in the file that we had before. So if I do cat, or if I do echo overwrite to file2.txt. Here, let's cat it first. So cat file2.txt. So that's what's inside of file2.txt. If I do echo CSCE overwrite to file2.txt, and now I cat it, it just overwrote the entire file. So the only thing that's in there is that single line now, which is overwrite. All right. So again, the same rules apply with the single versus the double angle brackets. If you have one, it overwrites. If you have two, it just appends it to the end of the file. But if you want to redirect standard error, the only thing here that's different is you just have to put the 2 in front of it to say, hey, I'm redirecting standard error. Okay, so that's like error messages, things that go wrong. Those things will be redirected in this case. Whereas standard out, if I go back, this is what you like console.log or like system.out.println or print in Python or echo or cat. These are all standard output things. Whereas standard error is just error messages. So warning file does not exist or something like that. That is what you would redirect. Okay. All right, so then there's a shortcut. You can actually redirect both of them at the same time. You can do it in this way where you do this 2 angle bracket and 1. You can do this. I don't like this personally because it's hard to remember. Or you can do the shorthand, which is just ampersand angle bracket. And the same rules apply here. You have 1 angle bracket, it overrides. If you have 2, it appends. But yeah, so if you want to redirect both standard out and standard error to the same file, you just do ampersand angle bracket. And there's no space here. If you put a space here, we'll learn later in the semester that ampersand is also a special symbol about when you're running your scripts and programs. So yeah, if we want to do both standard error and standard output to a single file, then you use this ampersand angle bracket. So just like always, there's multiple ways in Linux to do things. This gives you flexibility and stuff. Okay, so what about the left angle bracket or the less than symbol? Well, this redirects standard input. So I seldomly use or redirect standard input because I really don't see the point. It becomes a little bit more hard to understand if you do this, and it's more typing. So I seldomly use this, but this is just for information. So this operator, the less than symbol, will redirect a file's contents or a command's contents into another command. So you have a couple examples. So echo hello world, and then you put it at the end of the file. You put it at the end of the file with this command, and then you say, okay, well, I want to count how many. So this is a new command we haven't seen. This wc-l is word count. It also counts the number of lines and characters. So if we do wc-l on a file, it just counts the number of lines in a file. So if I do something like, let's see, wc-l, or let's do it without the option first, file2.txt, then it says, okay, you have 1 line and I think 10 characters. It's right here. If you do wc-l, file2.txt, it just returns 1 because you're saying, okay, how many lines are in the file? So -l just stands for lines. And again, if you ever have a question about what options are available, you just use the man page. You can type correctly. You can get more details about them. You get number of bytes or characters, number of lines, and so on, number of words, whatnot. Okay. So in this case, if we want to take something and figure out how many lines in it using the hard way, you can do this. So you're redirecting the contents of the file2.txt into the command word count versus just doing word count -l file2.txt. So you can see why this is kind of a little bit like not that convenient. So this operator, you can use it. Do you have to? Not really. If your program's good enough and it can read the standard input from the arguments, then why do you need this? You don't really need it. but it's there for your information. Okay. All right, so what about the 2 less than symbols? What does it do? Well, it doesn't really make sense because we can't append anything to the input, right? Well, it kind of does somewhat of that very thing. If you do this, what's called a here document operator, we're not going to be tested on this, so you can just, this is just for supplemental information. It allows you to kind of input interactively. So if you ever put like a slash at the end of your like command, so echo, hello, it brings this little line down here. So this little like caret key. It's saying, hey, I'm waiting on more input. And if I enter in world, press enter, then it still captures it and finds hello world. So let me move this up. So if I do echo, and then I put a slash saying, hey, I'm going to continue my like input to the next line. And I put world, it just prints hello world, just like you would normally have it. This just makes it easy to where you can do this with, instead of doing tons of things like hello world, if you have stuff that will overflow from one line, it just makes it easier to read. But yeah, it just says, that little slash just says go to the next line for the input. So this is very similar. It's saying, hey, just keep reading the input that you give it until you see this EOF symbol, which stands for end of file, or it's just a character that says, hey, I'm done. I'm done with my input. So if we enter this in, it says, okay, do the word count until you hit an EOF. So it says, okay, beep, boop, bop, bot, EOF. So once it sees this, it says, okay, I'm done. And it says, okay, well, I'm going to count how many lines are here with this command. I'm going to perform this command on whatever I input. So you've got beep, boop, bop, bot, and it returns 3 because there's 3 lines. So again, we won't be testing on this, but because I've never used this ever in my career. So yeah. Okay, so the more exciting part. So for the most part, I only ever use the standard out or redirection for standard out or standard error. I almost never use standard in and redirect it. You might use it in your 240, but for the most part, I don't really see the point. You can write a program that does it. Why am I got a beach ball? I don't know. Hello? Is Wi-Fi being stupid? Is my computer freezing? Okay. Looks like PowerPoint froze. Never seen that happen before. Force quit. Come on. Okay. Where were we? Okay, so we were at pipes. All right. So you probably never used this little symbol unless you were doing something like a comment or something. But this vertical line, which is found on the backspace key, right below your backspace or delete key, so shift backslash, you get it. It's called a pipe. So this pipe, what it does is it feeds in output from one command to another. All right. So if I take file.txt and cat it, I get this output. This is what's inside the file. If I want to do something else on that file, I can do cat file.txt pipe. Maybe I want to count the number of words or lines. You can chain commands together with this. So pipe just takes the output of one command and puts it into the input of another. So to give you a kind of a visualization of this, I created this morning, this like Mario pipe or whatever. So you take one command, you do cat cities.txt with a file that has all the cities or whatever of South Carolina. And it gives you this output, normally if you would just leave it there. But then what it does with this pipe operator is it chains it together and runs it through the next thing. So word count -L. So count the number of lines. And then it says, okay, I'm going to count them. I perform this operation on this output because it's being input into this command. and then I output 4, right? So you're just chaining commands together, or piping the output of one command to the input of another. So let's do something like this. So I already did it kind of here. There's more things you can do, so we'll learn later on in the semester the grep command. So what grep does is it allows you to search inside of files. So grep is also case sensitive, unless you say it's not. So I grep the output of this catfile.txt, which is just the contents of the file. And it's passing it into the grep command, which is searching inside of the file for something called hello. And then it highlights it and reports it, right? So all this is doing, all this pipe is doing, is just taking the output of one command and putting it into another one.
How do you have to do it with like the cat file? Couldn't we just use the command on the file itself?
Yeah, you could. So you could definitely do that. In fact, we can do it right now. So file .txt. So it does the same thing. But there will be at some points in your career that maybe this might be a better idea. For example, for like commands that don't allow you to pass in a file, they just do operations based off of what's in standard out or something, instead of being able to say, okay, wc-l file name, maybe the program or whatever you're using can't do that, right? It doesn't read the file in. So this way you could actually just dump the output to the command or program. You're redirecting it into the command.
So let's say you had like a bash script that would, or a shell script that would run on like a text file. You could use pipe to take the output of the text file and put it to that bash script.
Yeah, yeah. So like you can chain your scripts together, stuff like that. So you say, hey, okay, you have a hello world script that takes in the output of the hello world script and then passes it to another script. And you can keep doing this. You can pipe things as many times as you want. There's a point where you kind of think, okay, this is obviously you need to do something different because you don't want to pipe a million times, but you can pipe as many times as you want because this comes in handy when you're doing data manipulation. So what I'm thinking about for the lab this week is we're going to learn a couple more commands called cut and paste, I think, and we're going to have like this long data file of maybe cities or something like that, or countries in the world, and you'll take the file and you'll pass it through multiple layers of command. Instead of having multiple commands individually manipulating this data, you can just create one long command with pipes that will do all the data manipulation you want it to do. So I use pipes for that very reason. Instead of creating a big program that sorts through all this data in a file, I just pipe together some commands and it works pretty quickly. Better than spending a lot of time writing a big program for it. Okay, so a lot of you probably, maybe I mentioned it in some of the labs, if not all. The comment symbol for bash scripts is just a hashtag, pound symbol, whatever you want to call it. So that's how you do a simple little comment. All right, so wildcards. So remember that these two are wildcards. I'm prefacing this because next week we're going to get to regular expressions. These are wildcards. There's some overlap between wildcards and regex, but in this context, what we're about to go over, this is just for wildcards. All right. So what are wildcards? Wildcards help you expand things when you're doing bash. So if you have like 1,000 different files named file 0, 1, 2, 3, 4, 5, 6, 7, 8 .txt or whatever. You have 1,000 files with numbered 0 through 1,000. Wildcards help you do things on those 1,000 files without having to go and do them individually or doing a loop. So if I do touch text test dot tost1, test2, test3. Okay, well, I want to delete all 3 of these at the same time. So I just created them. So we got the 3 empty files. If I want to delete all 3 at the same time, all I have to do is test or do rm test question mark. I do that, it's gone. Because that question mark is basically like, think of it when you're playing like a card game, right? You have a wild card. It stands for one card or character. So in that case, it was the 1, the 2, and the 3. All right, so let's say, okay, I create some files. Let's say I do test 1, 0, test 2, 0, test 3, 0. So now I have some test files that have double digits at the end of them. If I do the same command, I do rm test question mark. Notice it doesn't get rid of these with the double digits, because again, the question mark only stands for one wildcard or character. That can be anything. So in this case, it was just 1, 2, and 3, not 10, 20, and 30. Right, so that's the question mark wildcard. And then the other wildcard is a asterisk. This asterisk is, think of, can't come up with a good example with like as far as card games, but it's 0 or more characters. So basically you say, okay, I have as many characters as I want, and it can stand for 0 or more. So let's do a couple more. So if I do rm test star, that gets rid of the 10, 20, 30 because it's matching 1, 0, 2, 0, anything. It could be any character at the end or none at all. So let's do an example of when it would do none at all. So touch test, test 1, test 2, test 10, test 20. All right. So if I did rm test question mark, then it would delete which ones? Test 1 and test 2, right? All right. So if I do star here, what would it delete? Which of these files? Yeah, exactly. So it would delete test because, again, star is 0 or more characters. So it doesn't have anything. It'll delete anything with the prefix test and nothing after it. It'll also delete test with anything after it. So if I do this, just like we said, it deletes all the things that start with test. Okay, so that's the differences between question mark and asterisk. So question mark, any single character, asterisk, 0 or more characters. All right, so now we're going to go to curly braces. So what do curly braces do? All right, this is where this comes in use. I rarely use this except for when I'm creating a bunch of files or directories named similarly. So far we've learned, okay, if you want to create multiple files, to do this. So touch, test 1, test 2, test 3. Okay. Well, now you can do curly braces. 1, 2, 3. And then you can put whatever on the outside of it. So what does this do? What it does is it looks inside the curly braces and says, I'm going to take one of those characters and put it there, in that place. So if we do it, it gives us test1.txt, test2.txt, and test3.txt. So you can do this for all kinds of things. You can also do ranges. So test1.5.txt, I think this works. And it creates 1 through 5. So it says, okay, I'm creating files named test.txt, and inside the middle of this, we're going to have 1 through 5. So either 1, 2, 3, 4, and 5. So using our asterisks, we're going to delete all the txt files. So they're all gone. So if I do touch test, or let's do a different one, robot 1.100 txt, what does this do? Creates 100 files with test 1, test 2, test 3, test 4, all the way up to 100. If I do that, it took a second, there's your 100 files. So you just created 100 files named very similarly without very much pain. So that's what the curly braces do. It works for make directory. It works for RM. It works for many of the commands if you want to delete certain files. So if we do rm, test or robot, sorry, robot. And let's say we want to delete 50 to 100. So if I do that, it deletes everything 50 and up. So yeah, so that's all that does. The curly braces just select, okay, one character or one number inside of these curly braces. You can also do ranges with it, like I said. But it's nice because you can create multiple files, named similarly, and it makes it just super easy to manipulate things. Okay, quotation marks. All right, so let's clean up some stuff. So star.txt. So that deleted all the text files. All right, so we've mentioned it a couple times throughout the class. If I do this, it works fine, right? But sometimes if you do echo hello world or hello star maybe, okay, sometimes it works. If I do hello star, all right, so quotation, what I'm trying to get here, and I haven't come up with a good example of it yet, I'll probably do these examples, is the quotation marks basically say, okay, do this, like this inside the quotation marks is what I actually mean it to be. It keeps it from expanding things like question mark and star, so that it's not interpreting, okay, well, star stands for something else. So if we do maybe cat, let's do touch star.txt, create star.txt. If we do cat star.txt, anyway, all right, so the example here is, okay, ls star.txt. So let's see, that's a terrible example. Anyway, so what I'm trying to get to here is these quotation marks are basically keeping things from being expanded. So if you have a star, it doesn't count as 0 or more anymore. It's in a literal star. Same thing with question marks and stuff like that. It doesn't interpret it as a special character in Bash. And sometimes I actually have like a bunch, this is one thing that's wrong and I need to correct it, is my Bash is different from your Bash because I modified mine even on the Linux lab, so I need to revert mine to what y'all have. Because a lot of the things that work for me sometimes don't work for you. So I need to fix this. But yeah, so just surrounding something by quotation marks typically keeps it from being expanded. So star.txt or question mark.txt will be literally looking for that file. All right, so command ABCD. Okay, yeah, there's a good example. So if we do make directory and we do ABCD, we do that, what does it do? It creates 4 different directories, right? Versus if we do make directory quotation A, B, C, D, it creates one directory called ABCD. So it keeps it from saying, hey, this is multiple arguments as well. All right. So if you come across a character that's special, like quotation marks, and it has special meaning, to get the literal version or escape the character, you put a backslash. So if we do echo hello world, for example, like that, then, and we want it to actually print the quotation marks. See, the quotation marks didn't print it because Bash said, okay, that's just quotation marks in terms of Bash. If we want to actually print them, we have to escape the character. So we do hello world, and then we do this. All right, so this is another thing. So you see also that exclamation point is a special character, so we have to escape it as well. Oh. Oh, that's why. Went too far up. So now we have the actual quotation marks. So instead of up here, we did not add the quotation marks. So if you want to include quotation marks in your like message or whatever, you have to actually escape them so that they're not interpreted by bash. And then, oh, one more thing about this. So the other thing is the new line character. So in Linux, it's /n. So this is one character. Even though it's 2 keys or on your keyboard, it counts as one character. So it stands for the new line character. So if we do echo, come on mouse, echo, and then we do hello -n world. Because I put it in quotation marks, it interpreted it as a actual like character, or the literal version. But if we do this, okay, why are we not cooperating today? Echo -e, hello -n world. There. So -e. So I guess echo, one of the things about echo is it always assumes that everything that comes after it is just literal in some cases. So you see why I'm messing up so much with this is I barely use this stuff. This is just good knowledge to know, to be exposed to know that, okay, the new line character is /n, and then if I get some kind of weird behavior, maybe I need to escape a character, like maybe a exclamation point or whatever. But it's not really something I remember all the time. I only do it when it comes out weird. And I very rarely remember, like I said, if you want to learn all these and figure out which characters are special characters and whatnot, you can. Otherwise, just when you get to a point and it's like, okay, this is weird, or can't find this or whatnot, just say, okay, it's probably an escape character issue. So, all right. So I was going to do a path review. This is for your information if you want to study it. Just goes over relative and global paths again, so that we can start using them like they're intended to be. So this is just a review of relative paths and how you can use them if you want to look at them at home. This is mainly because the summer course, a lot of students were like doing things like cd.temp or cd.temp, cd project, cd this, whereas you could just chain them together, or do cd ... this parent directory and then another directory or whatnot. So you don't have to do cd 1,000 times. Okay. So come to lab, we'll have a quiz this week and start working on your homework.